learning, made a lot of video-based training content on how to use Unity and other tools like 3ds Max, Maya, Photoshop, Adobe Audition, things like that. So a lot of different creative tools and how you can use them to make cool stuff. So a couple things about me. I'm based in Salt Lake City, Utah, which is kind of not quite West Coast. It's more like Southwest America. I can drive to Los Angeles in about 13 hours. A couple things about me. When it comes to making games, my favorite thing to do is rapid prototyping. And what I mean by that is I'll be playing a video game and I'll see something like a function or a feature or something happen. I'm like, oh, I wonder how they made that happen. And then I'll sit down in Unity and I'll usually recreate it and then throw that up on my GitHub and move on to the next project. I like to teach quite a bit. This is why I work for the Unity education team. My favorite genre of all time is fighting games. I travel for them. I commentate them. And I've been playing Street Fighter 6 probably more than is reasonably healthy. And my favorite food of all time is pizza. I know that's pretty stereotypical, but pizza is really, really, really good. And I generally, when I'm traveling for work or going anywhere, I make sure to find the local pizza and eat it. So I'm not sure if Toronto has like dope local pizza, but let me know if it does. Because I'll actually be in Toronto in 3 weeks. What day is today? No, about a month. Okay. So the first thing I like to do when I do these types of presentations is talk about how I got to where I am. I think something that's really left out in a lot of conversations is the journey we all kind of go on after school and figuring out jobs and working and what we learn and grow with. So I figured it'd be kind of fun to talk about that with y'all before we dive into, the industry itself. So for me, I went to college for music production. I was going to be a guitar player in a big band. I was going to travel the world. I was going to record music and edit it. And when I finished college, I was in this position where I was making really, really good money selling iPhones. And when I started getting jobs offers in the music industry, they were offering me not a ton of money. And so the choice for me was move to New York as an intern at a record label and try to figure out life that way, or continue where I am today and just, do what I was doing. So I decided to stick around and keep selling for a while. But in the background, I was doing a ton of content creation, right? Using my college degree to make videos with friends, record podcasts, record my own music, all that kind of stuff. And what that led to was me getting a job at a content creation place where we were creating training content on making video games. So as we're building all that stuff, we're making video game content, how to work in Unity, how to work in Unreal, how to model, create things, all that kind of stuff. And after that, in the background, I started getting really heavy into stream production, right? So we were then working on Twitch streams, whether it was our own or helping other people build up their Twitch streams with overlays and how to do the video encoding and all that type of stuff. And the combination of all that kind of culminated in me realizing, after editing hundreds of hours of training videos on how to make video games, that I knew how to do it. I knew how to write the code. I understood all the interactions. And I understood how to set up things so that when I got on virtual calls like this with all of you, my audio sounds reasonably okay. My video looks kind of good. And so now I'm here working at Unity because they saw all those skills and realized they needed somebody to do that. And now I tell people to make video games. And the whole reason I showed this whole windy path is just let you all know that everybody finds what they're doing in their way differently, right? So as an example, one of my colleagues who makes a lot of our products, he went from college straight into the gaming industry, working on mobile games like Marvel and a couple of different other ones. And then he discovered he had a love for education, ended up joining Unity as a developer, spent 3 years doing that, and then joining the education team with me to help develop products, right? So no matter what you're interested in doing, don't forget that everything you do is an opportunity to learn something really cool and fun, and you should dive in and take it from there, right? So even if you're doing stuff that you don't totally love, it generally makes it more fun and interesting if you think about all right, well, I'm not having a great time doing this, but what am I learning from doing it? Hope you get through it a little bit. Anyway, just some advice from an old person that can help you understand some of that. So that being said, let's talk about what it is that I actually do. So Unity is a real-time 3D platform. And I want to be clear about that because we call ourselves that instead of a game engine now. And the reason for that is that we can quickly render detailed 3D images. You could even take the phrase quickly, replace it with real time, right? And we have our definition. So we were rooted in games. We started in games. But the cool thing about this technology is that because games is all about recreating worlds, it became very apparent as this tech gets better and better and better that we can do more than just recreate worlds for entertainment. We can also create it for other stuff, right? Which opens up a ton of opportunity for folks learning to make games. So things like Unity, real-time 3D engines, or platforms are a stack of solutions that allow you to build stuff faster without recreating the wheel. So as an example, I'm not sure if you all are able to like raise your hands. I see all your cameras are off, but does anybody know like the mathematical calculation for how light refracts off of metallic surfaces? I do not, to be clear. I am not very good at physics. All right. If somebody in the chat knows, cool, congratulations. You're smarter than me when it comes to light. But the thing about that is not a ton of people know that, right? But that's already been solved in the world of real time. Somebody's already calculated that. So instead of making you recalculate that, what you can do instead is simply point a light at a metallic object, and Unity will calculate the reflection for you and let you see it, right? So it allows you as a creator to move faster and get things done more efficiently. What's good, Qubit? Hope you're having a good day. So, oh, bye. So with that, it helps you build things, and that's kind of our whole mission, right? Our mission is to put tools in the hands of creators like you so that you can go through and build things quicker and create the future of whatever, the industry is without having to reinvent stuff that we've already built. So this tech has gotten a lot better in the last 30 years. This is my favorite video game of all time. This is Final Fantasy VI. It's made for the Super Nintendo. We were released in like 1992, I think, maybe 91. And this is a 16-bit rendering system. And if you look, you can tell they're really leveraging the color well, right? Like you can kind of look over here and see like the God rays coming out of the sky and how they're using like different saturations of yellow blended with white to kind of get these different effects. You can see the purples and pinks being applied here, which is really just a lot of application of red mixed with different color pieces, right? But if you jump forward a little bit, you can start seeing stuff like this. This is Ori and the Blind Forest. And you can see the beautiful orbs coming out of the background. You see the light really affecting the purple of the thorns. You can see the blur effect. So things start to look really, really, really good, right? And then we jump forward to stuff like this, which was made last year, maybe the year before in Unity. This is from a project we did called Lions. These lions are completely simulated in Unity. Nothing about them is real, except for I assume there was a picture of a lion that the concept artist started with when they started drawing these creatures. But these are all completely simulated in real time using Unity lighting, including all of the fur, which is individually simulated using a tool called Wig, which is really powerful from what I'm. So again, it just gets better and better and better, right? Also, these little buddies are like super cute, so I really like this GIF a lot. There's actually a full video you can watch on YouTube. Hi, Joe. No doors closed. Fun fact, my dog has a no closed doors policy, so when I'm doing presentations, he'll usually walk over and push my door open. It's real great. So again, all of this done in real time. And what that does is really impacts the way industries move and how they create things. But before I dive into how all of that works, I want to talk about like why I like what I do. And then we'll talk about all the resources available to you to learn how to do this stuff. Spoiler alert, it's all free, so that's pretty cool. Okay, so why did I choose to be here? This stuff is always new, right? This industry is moving really fast. So I feel like I get to work every Monday morning and some new piece of technology has launched that I need to look in, right? The last 4 months, like AI has been a huge thing that is sweeping everywhere. And I've spent a lot of time now researching tools and algorithms and ideas and how it's going to impact those types of things, just as an example of how things are changing rapidly. I get to explore a lot of technology. So, I spend a lot of time thinking about Unity, of course, thinking about game development. But because of that, I do look at things like AI and ChatGPT and generative AI like DALL-E. But then also I spend time looking at like 3ds Max and Maya and ZBrush and how people are creating models differently. And then I look at rigging and then I look at coding languages. So I do a lot of different stuff. And then because I'm speaking to you all, I also have to look at like microphones and how they work. And I have to think about cameras, and I have to start looking at like better ways to encode video and edit video. So it keeps me really busy and it keeps my brain jumping from thing to thing, which for me is really exciting. This is a lot of problem solving, which I really dig. If you like puzzles, problem solving, figuring out challenges, this is a great spot. If I'm working on a game, it's figuring out a problem either with the code or figuring out a better way to do something. If I'm working on, say, like a marketing video or a project, it's figuring out ways to make the video interesting or exciting, or how to explain technology in a way that's going to make sense to people that maybe aren't in the industry, right? Or somebody who's never been exposed to this before. How do I explain this to a way that will get them excited, but then also make them want to learn and invest the time, right? Because learning a new skill takes time and it's hard. So the other thing is that everybody in this industry so far is really, really interesting. I have not met a person that I don't get along with for the most part, which is really, really exciting. I meet people all over the world. I meet teachers and developers, artists, and everybody is really focused on the same thing. How do we create really cool, fun experiences, whether they be games or architecture apps or whatever, so that people want to engage with whatever it is we're building? Okay, there's my sales pitch on why you should work in games. Let's talk about the opportunities available to you all. These are all of the different fields that are impacted by real-time 3D technology. So architecture uses tools like Unity to set up renderings of buildings so people can preview them, right? And the way I like to think about this is if you can light a building for, say, Fallout or The Last of Us or Mario or whatever game, that means you can also light a building for an architectural simulation, right? Because light is light and it bounces the same. And so what we're saying is when somebody wants to get an apartment or build a retail space, instead of looking at a picture or driving to the location, they can now just put on a VR headset and walk around and see the environment and make changes in real time to give feedback to the designer to make it work. XR is a massive industry that's exploding with immersive learning, immersive driving. It's impacting all of the other industries, and Unity is the #1 tool for that. Media and entertainment uses us heavily for like shot pre-planning, for rendering, for creating content. And then automotive companies use us to pre-build vehicles, test vehicles, show people how to fix vehicles. There's a ton of stuff there. And again, it's all designing an interactive experience, just like building a video game. And then on top of all of that, there's still video games that you can create as well, which is great. Okay, so here's some examples of companies that use us: Pixar, Disney, Haskell, Volvo, BMW, so pretty wide swath. And I actually wanted to show you all this. Hopefully this shares audio, but these are a lot of the industries that we impact, right? So gaming, film, education and training, automotive, and then of course architecture. So again, all fun things. But I want to focus on film for just a little bit. And hopefully, let me check really fast with Google because this is different. Okay, share tab audio. This is doing the audio. Perfect. Just want to make sure. So this is Baymax Dreams, and this is a short made by Disney, done completely in Unity.
I am Baymax, your personal healthcare destroyer. Self-diagnostic scan complete. I am experiencing a personality malfunction.
Oh, good thing I wrote this chip. It should pull your different personalities together while you charge.
So this is the 2D portion.
Hi, I'm Baymax. Hero said to pull myself together. I will pull us. I calculate that I am the most efficient Baymax. I will be the one to pull us together. Ooh, you talk fast. You are an anomaly.
Okay, so I'm going to pause it here and we'll talk about the shot because I just saw a good question come up. Someone said completely, and the answer is mostly completely. So some of these models and characters and stuff were all created outside and then brought in, right? So I would argue that these Baymaxes were probably modeled in something like Blender or Maya. I don't know which tool they used. And then they're brought into Unity to make these scenes and sequences. And the reason why this is so powerful, like let's look at this shot right here. So you've got this background blurring out. You've got this hand kind of coming in front. And then you've got like the eyes and the way the different lighting. So if they wanted to test something and say they were like, okay, we're going to change the scene color and composition. Maybe we're going to change Baymax's eyes to be like red and have them glow a little bit. And they wanted to rewatch the shot to see how it expands in a normal renderer. What they would actually do is they would change the color. They would adjust the scene. And then they would click render. And that would send this scene off to a render farm or to their machine. And they would wait for it to process. And then they would watch back the play blast, right? And that play blast would be anything from maybe 3 seconds to 10 seconds. And when you look at a frame, when they render movies or anything like this, you render each individual frame, and movies generally run at 24 frames a second, right? So that means for every second of video, you're rendering 24 frames, one frame at a time. And each one of those frames is usually in 4K resolution. So let's see, how many pixels? Let's look this up real quick. In a 4K image. So a 4K image has 8,294,000 pixels in it. So what that means, the way a renderer works, is going to shoot a line out array. It's going to hit that pixel and it's going to say, okay, what color is this pixel? It's going to do the calculation. It's going to return it, right? So for every single frame, that is going to do that 8 million times. So now you start thinking about, all right, I'm going to do a 10-second play blast to test this, which means there are 24 frames per second, which means there's 240 frames that have to get rendered. And that's 8 million pixels. So let's see, 8,294,400 times 240. So that means that play blast needs like 1, 2. It's like 2 billion pixels to get rendered. So that means they're sending that off, waiting for the processors to process 2 billion pixels. Probably takes 20, 30 minutes. Could be shorter, depending on how many computers they have. Shoots it back. They watch the play blast. And then they go, okay, cool. Is it what I wanted? Does it look right? And if not, they make more changes. Then they send it off to the renderer. It comes back. They watch it. And they do that cycle, right? And that starts to become very time-consuming as a film editor. So instead, when you're using something like Unity, you can change the color immediately and see how that impacts the scene. And actually, instead of showing you like video, I can actually show you what that looks like inside the editor. So let me stop presenting really quick on here, and we'll switch over. We'll just give you my entire screen here. Ladies and gentlemen, a Unity project. All right, once this loads up. So this is the Unity editor. This is a demo scene using an asset pack from a company called Cinti. Let's just take a look at this question mark, right? So I was just kind of making a small video about like how to make like a quest giver. So here's our little knight. They've got a yellow light shining over their head, right? And maybe I want to change the way things look from a daytime and nighttime perspective, because right now this is broad daylight, right? It's super bright. The skybox is nice and blue. So the first thing we can do is shrink some of this. We'll pop open our lights, and we've got 2 directional lights in the scene. It's a really interesting way to do lighting. So instead of going, all right, what time of day is it? I'll just change it to night really quick. So we'll go and find our light source. It's right here. I'll grab the rotation, and I'll just rotate it like that. And just like that, you see how fast that lighting situation switched? That saves me a ton of rendering time. And now I can go back to my my yellow thing here. And then it's like, all right, now it's kind of dusk, right? It looks kind of weird because our skybox is super bright. This directional light is also casting like some yellow on the scene, so I'll probably pull this up to get more dusk. And then we can also edit our skyboxes. Let's go see if we have any skyboxes in the scene here. Thank you all for enjoying my off the cuff demo, by the way. I wasn't planning on showing you some of this stuff, but then I was like, why not? Y'all should see like the cool stuff we're doing since you're working on hacking things. Let's go see here. Is that a skybox? No, that looks like a god array. Let's see. Let's see what this package hides skyboxes. Actually, what we do, Windows, go to rendering, we'll go to our lighting, go to our environment, and we have a default skybox right here. Where's that showing up? Okay, so we can look at different skyboxes here. And it looks like we're using a default skybox for this project. And I wonder if they have the sky projected in an interesting way. Oh, they have a sky dome. That's what it is. So what they're doing is they're using a sky dome and putting us inside the sky dome. So if you see, if I zoom all the way out, now there's our default skybox right there, but the sky dome is actually what we're projecting into. That's kind of a cool way to do it. And then we have the simple sky dome shader right here. So what I think I'll do is I'll actually turn that off and send us back into the scene. So we'll just use the default like world with some clouds. So now the sky looks dark, looks kind of scary. Now what we can do is maybe we want to highlight our character, right? So let's actually create a new light. So I'll go to light and we'll make a spotlight. So now I have this spotlight right here and it's right in the center of the scene. and I can drag it over my knight. We'll just kind of come here. I don't like the angle and the rotation of this, so I'm going to reset that to be there. I don't know why it's rotated at an angle. That's super strange. I wonder if maybe the scene itself has a rotation put to it to add some style. That's all right. We'll just move this around. We went way too low. Now the light's below the ground. It's not what we want. All right, it's time to do the lazy shortcut. Let me show you all a trick. I'm going to put this right here inside the knight, and then we'll reset the position, and that'll snap it right to the knight. That'll make it easier on us. And then we can pull this up, and as you see, this light is now affecting the knight, and you can see how it's changing kind of how that color works. So what I'm going to do is probably pull this in front of the knight a little bit, and then we'll rotate it so that it shoots right, kind of like it's highlighting them. So now we have this light, and I can quickly just change what color to change the mood of this scene. So I can do like red if I want it to be more like scary or ominous, and it kind of adds that tone. But I can actually change and modify the light quickly without having to re-render anything, and that's what makes real time so powerful. I can also add different pieces, different effects. If I wanted to create like a particle system, I could also do that. I think there's already some VFX in here. Let's see what prepackaged effects I've been given. Ooh, what's this fire do? Let's put a fire out. So now there's a fire in my scene just like that. And we're already looking at how it renders. And we can see the light and color coming off of it. And when we look at our game window, this is my camera shot, I can now see everything really clearly and really quickly. So again, that's super fast. I don't have to worry about frame by frame rendering. I can just look at this and say, okay, this is what my scene looks like. And I like it. It's got 3 knights in it. There's a glowing yellow question mark. Everything's cool and everyone's having a good time, right? So you can change things quickly to really modify how the scene works. Cool? Cool. All right, let's minimize this. We're going to skip Baymax. Maybe. All right. So that's kind of how you can use that kind of stuff. Now imagine applying that to something like automotive, transportation, manufacturing. You can take this kind of tech, and now we can build an exploded view of like a forklift, or we can test how things would work in different areas, different functions. So again, all of this applicable to a bunch of different industries. Let me show you the architecture shot. So this, again, all fake. This is all rendered. This is the design of a company office we did. And now it's like, cool, how does this look? You see the light coming in the roof on top, and we can really show them what it's going to look like at any given point in the day. So all you're at the point, if you can make video games, you can also recreate the real world, which is kind of exciting, I think. All right, let's jump to this next part here. So this is something that's really important to talk to you all about. So Unity is free for students, and y'all are students. Now, there is a caveat there. Because of government-based data privacy laws, you do have to be 16 to get a free student license. But if you hit this link, you can actually sign up for a free student license using your school email. And what that does is it gives you access to Unity Pro. You also get access to the Unity, the Polygon Education Bundle for free as well. This is an asset pack you can use to design and create games. And this asset pack is actually what I was using to create this scene right here. So you get access to this full asset pack with all the scene building, world building stuff. So you can start building and creating right away from Cinti. Cinti is an incredible asset provider. They make really, really cool stuff. They're used in a lot of products and projects. I use them all the time to build demos and all kinds of cool content because they have trees and buildings and people. They have all different styles from like knights to robots to monsters. Cinti's great. So you actually get free access to that as well. You get a free pack from them. Yeah, and it's that easy. You just hit the link that I dropped in chat and you can get your free Unity license and then start learning and using it. But when you have that, you're probably like, cool, but I want to learn how to use Unity, right? I mean, you got to learn how to use the thing you got. And that's where Unity Learn comes in. So Unity Learn is completely free. It's learn.unity.com, and it's all kinds of learn content for you. So places to learn game dev, right? There's YouTube, of course. I use YouTube a ton for different tutorials. We have a lot of Unity creators that we call them insiders that we actually help with YouTube content. So we actually give them inside access so they can build better, more interesting tutorials and actually teach you stuff correctly. But then we also have Unity Learn, which is built by our team internally with full content and projects on how to use Unity. Exactly. Nick knows what's good. Brackies. I miss Brackies. I wish they were still making content. So yeah, people like Brackies and other folks doing amazing work. And then we have Learn, which is dedicated content that teaches you how to use the editor directly, teaches you about the industry, teaches you how to create stuff. And again, it's all free. It doesn't cost you anything. Y'all are welcome to use it. Okay, so that was my entire presentation. I didn't want to spend like an hour yelling at y'all because I'm sure you're want to get back to hacking. But I do have a couple hackathon tips for you if this is your first hackathon, and then I'm happy to answer any questions from any of you. So, hackathon tips: hydrate, drink water. Your brains work better when there's water in your body, so make sure to do that. Water is good for you. Make sure to take breaks. If you're working on something and you get frustrated, you get stuck, get up and walk away. It's a very commonly known thing in the world of like software development or game development, any development. Sometimes you get stuck on a problem and your brain will keep chewing on it in the back of your mind, whether or not you realize it. And then the answer will hit you. Or sometimes you're too close to a problem and you need to just step away from it and like get a new perspective and rethink to find the answer. So if you start to get stuck on something and like you've Googled it, you've talked to a couple co-jammers, you've met some people and you're just not sure what to do, take a walk. Like get out, get some air, take a water bottle with you, sip some water while you're walking. Make sure you all are collaborating together and practicing together. And also make sure you're having fun. Because if you're not having fun, that can really take away from the experience. If you're not having fun, figure out why and find ways to make it fun for yourself. Let me see where I'm at. Sure. Okay, cool. So yeah, with that being said, I'm going to leave the tips up. But does anybody have questions I can answer for you about the engine, tools we offer, the industry, anything like that? I would love to take time to answer them for you all. And I think you can unmute and yell them at me, or you can type them in chat, whichever works for you.
Hello.
Yo, how's it going?
Hey, just wanted to say I love the presentation. I'm actually not even like doing this full hackathon. I was just in the Discord server, and I decided to hop in. I had a question.
Cool.
I want to get into like VR, AR development, and like specifically procedural generation. So I'm just wondering, how would you get started with that?
Yeah. So procedural generation is a big thing, right? I would start like, procedural generation definitely has some code backing tied to it, right? So you definitely want to learn software development practices and principles.
Yeah.
Object-oriented programming is really important. I don't necessarily think there's a specific language you have to learn. Obviously, if you want to do it with Unity, you're going to want to learn C#. That's the language we code in here. But I mean, you could learn Java. The cool thing about programming is it's kind of like learning a language, like a Latin language, right? If you know Java and you understand all the principles of object-oriented programming, it's not super hard to move over and learn C# because the syntax might change, but the methodologies and the functions don't change that much, if that makes sense.
Okay.
But yeah, I would start with that. I would also say from like a procedural perspective, after you've got some coding, I would start looking into like the rules of proceduralism and how it works. And then on the VR side of it, it's really about learning how VR works. The cool thing about virtual reality, and I say this and some VR people might disagree, but like a lot of the principles of creating games and creating virtual reality are the same. Design is the same. What changes is when you start rendering stuff, right? Then you have to think differently because you're rendering it in a situation where you can walk around something versus on a flat screen. So you have to think differently there. And you also have to optimize really well because you have to make sure that it runs at a specific frame rate depending on the headset to avoid motion sickness or simulation sickness. So that's really the things I would think about. And John, you're absolutely right. Like, yes, we absolutely have, we are one of the #1 VR development platforms. So like shameless work self-promotion, you could just learn Unity. And you'd be well on your way, right? We have it's called the XR Interaction Toolkit. It's built on top of OpenXR, so it works with literally almost every headset on the market. That's what I use to develop for. I don't think you can see it in the background, but I have my Meta Quest back there. That's what I use it to develop on. Is I use the OpenXR. I use the XR interaction toolkit with Unity as most of the dev work I do. But yeah, that would be my recommendation.
Okay. Yeah, I have some like experience with Java, and I've been doing a lot of web development.
Oh, cool.
Have you ever heard of anything called A-Frame?
I have heard of A-Frame. Yeah.
Would that be similar to Unity? Like,
I mean,
I would need
it's
to
a
like
different.
fully learn C sharp
Yeah.
to
I mean,
get
it's a
started in
different.
Unity.
Definitely, it's a different framework. I haven't used a ton of A-Frame. When I was looking into it, it was probably 4 years ago. So I'm sure it's come a long way. Um, I think it really depends on what your target experience is, right? Like if you're targeting a headset not through web deliverable, then you probably want to look at something like Unity Unreal. If your goal is to have all web-based AR or VR, A-Frame's a great option.
Okay. Yeah, I'd be looking forward to like the future and then seeing how to get more involved in the VR industry. So I probably would have to learn Unity or Unreal.
Yeah, that would probably be a really good recommendation. And of course, I work in Unity, so I would say go learn Unity. But again, like learning how to do anything is important, right? And the cool thing is, once you've learned one of our tools, you can learn a lot of other tools. So
Sounds good. Thank you so much.
no worries. Goosehacks dropped a question in the chat, and I can't believe the page is still up. So they asked, like, what's the biggest project I've ever worked on? So there's two. This one is called Swords and Shovels. I worked on this when I was at a company called Pluralsight. This is actually the first full game dev project I worked on. And what had happened was we were building a lot of Unity content, and Unity hired the project lead to go be their master trainer. And so I was the only person at the company that knew anything about game dev. And so they're like, well, this is your project now. Good luck. So this was a game that we reverse engineered to teach people how to make games. It was called Swords and Shovels. And so we actually made kind of like a dungeon crawler clone. So this was a team of about probably 20 people when all was said and done. We had 5 or 6 software developers, programmers. We had 5 or 6 artists, and then we had some production people and some lighting people. But we actually built like a vertical slice of the game, and then we went in and reverse engineered and taught everybody how to build it in Unity. So probably the first project we ever did, and I actually led the software developers and taught them all, like not taught them all, but like managed all of them building the entire code layout of the game in Unity. So this is just a trailer for it. This content has been deprecated. You notice it's even got the old Unity logo, the old Pluralsight logo. But yeah, we built this over about a 2.5 to 3 year period. We even took it to GDC and had a playable demo on the floor of GDC. It was really cool. The other one that I worked on, and actually this is something if y'all want to watch a fun series, just I can find it really quick. I'm gonna find Unity's YouTube. Was a game that we actually just recently did. It's called, let's see, where's my playlists? So we did a series called Scope Check, and we did it live on Twitch and on YouTube. And we actually built a game live with the community in 8 weeks. So let's go find like where's the testing level? Yeah, we'll go to the testing stream. So we actually built a game where you were in a school cafeteria, zombies were kicking the door in, and monsters, and you were throwing food at the monsters to try and stop them from eating you. So we did like heavy feedback on testing, and we did the game in 8 weeks. And there's actually a GitHub repo for it. You can download the project and the assets and play with it. But yeah, so we actually made the game pretty quickly. Trying to see if I can find where we actually played the game. Here you go. Yeah, here's some actual gameplay. So this is an early prototype of the game. We still didn't have our main character, so we were just using a cube with a little nose. And we were just throwing food at them. You could throw sandwiches, hot dogs, tacos, or pizza or pies at the enemies. So we built that in about 8 weeks, live on Twitch. It was really fun. And now the live video, the playlist is on Unity's YouTube, and you can like watch the whole thing. So yeah, pretty great. Have I done game jams before? So I've actually never participated in a game jam. I've run four or five of them. but I've never actually been able to sit down and just do a game jam over a weekend. So I'm hoping to participate in Global Game Jam in January. We'll see how my schedule lines up. Any other questions? I'm presenting to everyone. Oh no! Yeah, I already knew that. Thanks. Thanks, Google. Google's really worried that I'm going to show you my Premiere timeline, even though it's just clips of video games. Did it just crash?
Hey everyone, I think the call might have crashed for him, but I think that I guess that wraps up the today's Unity workshop. Hope everyone had a good time, and sorry if the call crashed. But hope you do good on the rest of the hackathon, and hope you get into Unity. Bye.